students, welcome to the lecture number 16 of chapter 6. Till now we have completed every concept and every theorems related to parallel lines. We have completed the theorem number 6.2, 6.3, 6.4, 6.5 and 6.6 as well as two axioms 6.3 and 6.4. So in this lecture we are going to discuss about some problems from exercise 6.2 and some examples also, right? So let us start with the first example. The first example here given that in the given figure, in this figure PQ parallel to RS. This line PQ is parallel to RS, right? And MXQ angle is equal to 135 degree. MXQ, this angle is 135 degree. And MYR angle is equal to 40 degree. MYR is equal to 40 degree. So this data has been given in this question, right? The data are PQ and RS are parallel. This angle is 135 degree and this angle is 40 degree. Now you have to find the measurement of the angle XMY. XMY. So we have to find out this angle's value. Okay? How can we find it? If we can draw a line passing through the point M. Okay? So we have to draw a line passing through the point M such that this line AB should be parallel to the line PQ and that line also parallel to the line RS, right? According to the theorem 6.6, if two lines are parallel to a common line, then that two lines are also parallel. But here it is given that this line and this line are parallel. Now we have chosen or we have drawn the line AB, which is parallel to this line and this line also parallel to this line. It means all the three lines are parallel. Understood? So solution here, let us draw AB line, okay, passing through which point? Passing through the point M, okay, such that this line AB should be parallel to the line PQ and this line AB is also parallel to the line RS, such that AB is parallel to PQ and that AB also parallel to RS. Understood? So that all the three lines are parallel. Understood? Now we will find this total angle XMY. Okay? So, if we want to find this angle, so we have to first find this angle, that means this angle, then we have to find this angle. And if we add these two angles, then we can easily get X and Y. So, our target is to find this angle. Okay. So, for this, consider the line PQ and the line AB. PQ and AB are two parallel lines, right? So, here PQ is parallel to AB. PQ is parallel to AB. Okay. And XM is a transversal line or not? Yes, it is a transversal line. XM is a transversal line. And this transversal line intersect PQ and AB at X and at M. Understood? Which intersect PQ and AB at X and M. Understood? Now, see, these two angles are known as which type of angle? These two angles are known as which type of angle? They are co-interior angle as they both lie on the same side, right? And they are interior to each other. Hence, these two angles are known as co-interior angles. Okay, so the angle QXM and BMX are co-interior. Understood? Next, according to the theorem number 6.4, we have discussed that the sum of any two co-interior angle is equal to 180 degree according to the theorem 6.4. Okay, implies this angle plus this angle is equal to 180 degree. Why? Due to the theorem 6.4. You have to write the reason always. Now, QXM, that means this angle is 135 degree plus BMX is equal to 180 degree. So, BMX is an unknown value, so we have to find this value. BMX is equal to 180 degree minus 135 degree. Hence, we find BMX is equal to how much? 45 degree. Understood? So we find that BMX, that means this angle is 45 degree. Right? Now we will find this angle's value. Okay? By considering the line AB and RS. Let's see how it is proved. Now, see, AB line and RS line are parallel and MY is the transversal line which intersect the line AB at M and RS at Y. Okay, now AB is parallel to RS and MY is a transversal line. MY is transversal. Now, tell me, what is the relationship between this angle and this angle? This angle lies in this side of the transversal line and this angle lies in this side of the transversal line, right? And they both are interior. So, these two angles are known as alternate interior angles. Okay? And BMY angle and the angle RYM are which type of angle? Alternate interior angles. Understood? Now, remind the theorem number 6.2. According to the theorem 6.2, if a transversal line intersect any two parallel lines, then the pair of alternate interior angles are equal. Understood? So here BMY angle and RYM angle are alternate interior angles. So you can write these two angles are equal. Okay. So you can write the angle BMY is equal to angle RYM. Okay. Next, BMY, that means this angle is equal to RYM. What is the value of RYM? This is 40 degree. Hence, if it is 40 degree, then this angle must be 40 degree because these two angles are alternate interior angles. So it is equal to 40 degree. Understood? So we find the angle XMB 45 degree and the angle BMY to be 40 degree. Now you have to find the total angle. Total angle means XMY. Okay? Suppose this is equation 1 and this is equation 2. Now you have to find XMY angle. So now XMY angle is equal to this angle plus this angle is equal to how much? Is equal to 85 degree. Hence we find the required angles measurement XMY. Okay. And now coming to example 2. According to the example, it is given that in the following figure, the line AB is parallel to the line CD, right? So the line AB means the total line, is parallel to the line CD. CD means the total line. Okay? So this line is parallel to this line. Again, CD is parallel to EF. EF means this line and CD means this line. So EF is parallel to CD. So according to the question, the line AB parallel to CD and the line EF also parallel to CD. Hence, two lines are parallel to a common line. According to the theorem 6.6, if two lines parallel to a common line or parallel to the same line, then the two other lines will be parallel to each other. This is theorem 6.6. Okay? So, according to theorem 6.6, we discussed that if AB parallel to CD, and another line EF parallel to the same line CD, EF parallel to CD, okay, then the two lines will be parallel to each other. So we can write AB is parallel to EF. Then AB is parallel to EF. Okay. Next, also EA line segment, or you can say the straight line, is perpendicular. This is the symbol of perpendicular. I have told you this is the symbol of perpendicular, this is the symbol of parallel. Okay, so the line EA, this line is perpendicular on AB. AB means this. So the line EA is perpendicular on the line AB. It means the line EA intersect AB at an angle 90 degree. Perpendicular means 90 degree. So the line EA intersect AB at an angle 90 degree. This is given. Understood? Next, the angle BEF. This angle is 55 degree. Okay? Then what you have to find? You have to find the value of X, Y and Z. This is X. X means the angle HBE. Y means the angle GDE and Z. That means this angle. So we have to find this unknown value of the variable. Right? So, how can you find it? See, if you consider the line CD, this is the line CD and the line EF. Both the lines are parallel. And this is a transversal line. Okay? So, write it. From the figure, CD means the total line, right? CD is parallel to EF. And this is a transversal line. ED is transversal. Okay. Next, if this is the transversal line and these are the two parallel lines, then according to the theorem 6.4, the sum of one pair of co-interior angles are 180 degree. Now this angle and this angle are co-interior angles because they lie on the same side of the transversal line and they are interior. So these two angles are co-interior, and according to theorem 6.4, the sum of these two angles must be 180 degree. So we can write Y plus 55 degree is equal to 180 degree. Why? Because theorem 6.4. These two are which type of angle? Co-interior angle. Co-interior angles. Okay. Now from this you can find the value of Y. Minus 55 is equal to 125 degree. This is the value of Y. Understood? Next, we will find the value of X. Okay. So here we find that X is 125 degree. Now consider the line AB and CD. AB and CD are parallel. Okay. Consider AB parallel to CD and AB parallel to CD, and DB is a transversal line. This is a transversal line, and DB is transversal. Then tell me, what is the relationship between this angle and this angle? These two angles are known as corresponding angles because both lies at the same side, and one towards the exterior, one towards the interior. So these two angles are known as corresponding angles. Then according to the theorem 6.3, we know that if a transversal line intersects any two parallel lines, then the pair of corresponding angles must be equal. Since these are the two parallel lines and this is the transversal line, then the pair of corresponding angle must be equal. Okay? Hence you can write implies this angle is equal to this angle. So x is equal to 125 degree. Reason is axiom 6.3, and these two angles are known as corresponding angle. Understood? Now we find the value of x. Next, what is remaining? We have to find the value of z. Okay. So for finding value of z, you have to consider the line AB and EF. Now AB and EF are also parallel. Okay. So again, AB is parallel to EF, and this is also a transversal line or not? Yes, transversal line means what? It should cut or it should intersect the line at two distinct points, right? Here also this line EA, okay, intersect EF at E and AB at A. So EA is also a transversal line, okay, and EA is transversal. Okay, then this angle and this angle, forget about everything, forget about CD, forget about B, only consider the line EF and AB. This is the transversal line. Now this angle and this angle are known as which type of angle? For the line AB and EF, they are co-interior angles. Okay, this angle and this angle are co-interior because they both lie in the interior side of this two lines and they lie on the same side of the transversal line. So these two angles are co-interior angles. So you can write, according to the theorem 6.4, the sum of two co-interior angles is equal to 180 degree. So you can write this angle means EAB. EAB plus this angle means AEF, the total angle, is equal to 180 degree due to theorem 6.4. Understood? Now what is the value of EAB? EAB is 90 degree plus AEF. AEF, this total angle. This total angle can be written as Z plus 55. So Z plus 55 is equal to 180 degree. Implies these two should be added. So Z plus 145 is equal to 180 degree. Now Z is equal to 180 degree minus 145 degree is equal to how much? Is equal to 35 degree. Hence we find the value of 35 degree HZ. Okay.